Hello, welcome back to our channel. I am Anisha, your maths faculty for class 12. We have started solving the questions of chapter 5 of class 12, that is continuity and differentiability. In this video, we will do the question number 21 and 22 of exercise 5.1 of this chapter, continuity and differentiability. Let's start. Okay, so in question number 21, what we have to do? We have to discuss the continuity of the following function. Okay, we have to discuss about the continuity of this functions. Okay, as you can see here, first of all, focus on f of x. F of x is, so if we start with, so before starting, I'm giving you an idea how you can think for this question. Okay, as you can see, f of x is defined as sin x plus cos x. F of another for B question, it is defined as sin x minus cos x, and C is like product. What we are doing, we are just finding the continuity of sum of two function, difference of two function, and like multiplication of two function. So are you like eager to use something? Yeah, you are right. You are going in the right direction. Yes, we're gonna use the property of continuity here. What is the property of continuity? Let me like state it for you if you don't remember that. So let A be any point in real where we have to like check the continuity. Okay, if we have two functions f and g such that and if I told you this symbol, this like if you can say reverse e, it is defined to say as such that. So f and g are functions such that f and g are continuous at x equals to a. Then by algebra of continuity, what we have first, f of x plus g of x is continuous at a. Second, f of x minus g of x is continuous at a. Third, f of x dot g of x is continuous at a. And fourth, that is last but not the least, that is f of x divided by g of x is continuous at a. But here we have a condition that g of a is not equals to 0. Okay, so from all this, what we have, if f and g are continuous at a, then their summation and their subtraction, their multiplication, their division is continuous at x equals to a. So what we gonna do? We're gonna use this algebra to solve this question. Okay, so as you can guess, if I have to check the continuity of say f of x function, which is defined as, if I start with a, so our f of x function is defined as, it is defined as sin x plus cos x. So as you can see, if I take say my g of x as a function of sin x and h of x as a function cos x. If I like find, if I like find that my g is continuous at some point and h is also continuous at that point, then we can use this algebra that f of x plus g of x is continuous when f and g are both continuous at that point. So we're going to use this algebra only. So for that, what we have to do? We have to say about we have to tell that the function g is continuous, function h is continuous. Okay, this only valid when both of them are continuous. Note that. Okay, if I like make a note point, so the note point is both of them must be continuous. Then only you can say the following results. Okay, this is the important part. Everywhere, every guy is like think that if one is continuous and another is not continuous, then also I can say this, but no, you cannot say. You can say, you can use this property only when both of f and g are continuous. So let's begin. So for that, what we have to find? We have to check the continuity of g and h. So begin with g. Our g of x is defined as sin x. As we know that the domain of the sine function is nothing but whole r. So function is defined for any real number. So let me start with x be any c, a real number. A real number. Okay, so what we have to say that the function g is continuous. Like we not say, but yeah, in at the end we are gonna say that the function g is continuous or in all r. But right now we are checking that condition. Okay, so if we start, what we have to do? We have to find the limit. So as you can see, we know that domain is whole R. So G is defined for any like for if we are started with any arbitrary C in the domain. So G is defined at x equals to C. Now we gonna find the limit of x tends to C, G of x. This will be nothing but limit of x tends to C sin x. We know that when we have to find the limit of sign, what we always do, take the like we will gonna change the limit, that is how we gonna change it, that when if I take my if I want my x tends to C, so if I try to say my like x as my if my then we can say if my h is tending to 0, then h plus sorry C plus h will tends to C, right? Okay, I want my x tends to 0. So if my h tends to 0, then my C plus h tends to C. So we will gonna use this. So what we will do is limit of h tends to 0 sine of C plus h. As you can see, if my h tends to 0, then C plus h tends to C. What we want here also. So now here what we will use, that limit of h tends to 0, h tends to 0, we will use algebra of sine a plus b form, that we know that this is nothing but sine c cos h plus cos h sine c. Now here our c is work as a constant here, so this limit will be comes out to be sine c. Limit of h tends to 0 of cos h, we know that when h tends to 0, cos h is nothing but 1, and this will turns out to be if I had made some mistake, this is okay. This is a yeah. This is cos C multi sine H, right? So if my as cos C will comes out and limit of H tends to 0, when H tends to 0, then that means sine of 0, and we know that sine of 0 is nothing but 0. So this will be turns out to be sine C. As you can see, function value at x equals to c. If I write my function value, that is gc is nothing but sine c. This is my function value, and you can see that my limit value is also sine c. So from here, what we get? Function value is same as limiting value. So this implies g is continuous at x equals to c. So we are like started with the arbitrary number c in the real. So from here, what we get? G is continuous in all its domain. So what we get? So what we get, our g, that is g of x equals to sine x, is continuous function because it is continuous in at all its domain points. Similarly, other what we want to check, we have to check my h of x is continuous or not. So similarly, you can do that if my h of x is defined as cos x, then you can easily define that this function is also a continuous function. Same thing you have to do. You will also check it. Your like function value is defined. We know that its domain is whole R. So similarly, your limit. So limit of x tends to c for arbitrary real c, cos x. This can be written as limit of change the limit, that is limit change to h tends to 0 cos of c plus h. Now using the algebra of cos of a plus b, you can like easily find this limit will be nothing but c cos c. So this is like homework for you to say that this is continuous at all its domain. That means homework. What is homework for you? To like find its limit, and you will gonna find that it is same as a function value, so it is continuous. So from here what we get, my g of x and my h of x both are continuous in all its domain D, that is nothing but R. Both have the same domain, that is R. So what we have, that my sin x function and my cos x function are continuous. So from here, you can go on. You can easily say that any trigonometric functions are continuous. This will come in the next question also. But what I'm trying to say, if you have find your sine and cos, then you can move to any trigonometric function, because we know that for any trigonometric function, sine and cos are the base functions. Okay, so what we get, sin x and cos x are continuous. Now by using algebra, continuous for any x equals to c belongs to real, that means for any real number c. So by algebra of continuity, what we get, first of all, a part, that is nothing but f of x, which is defined as sin x plus cos x. It will be continuous just by using algebra, that when h is continuous, g is continuous at a point, then h plus g is also continuous. So this will be continuous function. Why continuous function? Because sine and cos are continuous at each and every point. So f of x will be continuous at each and every point. Similarly, b, that is nothing but f of x equals to sin x minus cos x. Same using the algebra. It is also continuous. Now you can, I think, go for your c also. It's very easy for you. You can also think that sin f of x, it is defined as sin x multi cos x. We use the product rule of the continuity. Then if like this is also continuous, this is also continuous at x equals to c, so its product also continuous, so this is also continuous function. So what we have find, that sin x plus cos x is continuous, sin x minus cos x is also continuous function, and sin x multi cos x is also continuous function. So we are done in this question, because we have to discuss only about the continuity, and we have find that all of this a, b, and c are continuous functions. Now let's move to next question. This will be a very important question, and I think I can add more. In this, we have to discuss the continuity of cosine, cosecant, secant, and cotangent. If I write it in short, that is nothing but, if you not able to recognize what are they, these are nothing but cos, cosec, sec, and cot. So if I want to write like I will give you in the homework the next part, but I will add it in the last. So in question number, now we will do question number 22. In this question, what we have to discuss, about the continuity of this cos, cosec, sec, and cot functions. Okay. Now, as you can see, like earlier we have find in question 21, what we did? We did that sin x and cos x are continuous functions. We're gonna use this only. I have already told you, when you have knowledge about your base functions or of the trigonometry, that are nothing but sine and cos, then you can easily find each and every another trigonometric function. So we have already done with the cos part. That is means my cos is continuous function. Now let's move to cosec. As you can see, cosec is nothing but, you know that this is nothing but 1 upon sin x, and we know that its domain is nothing but r real minus n pi, where n belongs to integer, right? Now since by here also we have some another algebra of continuity, we know that if my, say, f and g are continuous at x, not another algebra, we are using just divisor, right? Or if I add one more for, if you want it as a special case, when f and g are continuous at x equals to a, then in 21 I have wrote you 4, right? F of x plus g of x, f of x minus g of x, f of x multi g of x, f of x upon g of x, and last will be for 6, if I add, that is 1 upon g of x, such that g of a is not equals to 0, is also a continuous function. Sorry, not continuous function, is continuous at x equals to a. So from here, as we know that sin x is continuous for all x. Now we are looking only for the domain, that are r minus of this n pi. So from here, as this is continuous in all this domain points, so this function will be continuous in all this domain points. So from here, what we get? Cosec x is continuous function. Similarly, I don't think there is a need to tell you about all, but this is, say, this is 1, this is 2, this is 3, this is 4. 1 and 2 are done. Now if I try 3, I just write the form. So we know that sec x, it is nothing but 1 upon cos x. And we know that cos x is continuous in all its domain, but here as it is 1 upon cos x, we have to find its domain. So its domain will be all those points in the real where cos is not 0, that is nothing but r minus 2n plus 1 pi by 2, where n belongs to integer. Okay. So this is our domain. So we know that cos function is continuous for each of these points in the domain. So 1 upon cos x will be also continuous by using this algebra. By using this algebra. Similarly, fourth is nothing but this is cot x. Cot x, we know that cot x is given by cos x by sin x. We know that its domain D is nothing but r minus n pi. N belongs to natural number, and we know that cos x is continuous for all these points, sin x is continuous for all these points, so there like a division will also be continuous for all these points. So by this also we get cot x is also continuous. Similarly, we have another, we are done with cos. Homework for you will be for sin and tan. We know that tan x is also given by sin x upon cos x. So you can like find its domain, and we know that cos and sines are continuous for all real, so they are also continuous for that particular domain also. So tan x is also continuous. Now, what I am trying to say, this will be very important for you. This trigonometric, you should remember that this trigonometric functions are continuous in which of the domain, because this will be very helpful for you, like solving the higher questions, and like they are the basic questions. I don't think this like this type of basics they will gonna ask in the examinations, but like they can directly ask you the questions like checking the continuity about sin x plus sec x. You should be like um, be aware where how to check their continuity. You what you have to do here also, you have to use your algebra. Nothing hard and fast rule is there. So these questions are the basics. You have in this 22 question is very important question, because you here you have learned what you have learned here, that the your all trigonometrics, where your all trigonometrics are in which domain they are continuous. This you have find here. And now what is the important question that you have did in question number 21, that where you have to how you use this continuity of your trigonometric functions. This is very important part of you, and like this kind of questions like asked frequently in the board exams. If like you can see this type of questions, like as they are very easy, like here you have to check only for sin x plus cos x. They are very simple. This can be asked for 2 marks, max 2 marks, but like they can divert the questions in another language, so that, but what is the base here there also, there also with the base of like this trigonometrics, there is the use of the trigonometric also. So it's very important to you guys to know that where your particular trigonometric functions is continuous or not. And I hope you understand this very carefully, like sorry, very clearly in this question number 22. So that's all for this video. We have completed question number 21 and 22 of exercise 5.1. I hope you guys understand these questions. If you have any doubt, just ask me in the comment section. I will like try to solve your question doubts as soon as possible. Till then, goodbye. Please like and subscribe.